Hello and welcome to another exciting episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is Jeffrey Hawthorne. Phil is sleeping.
Hopefully not. He's probably still driving home.
Yeah, well, that's a good point. But he visited briefly, but he said he had to go. So, what are we doing? We're going to main screen, and we're working on this Fight Go Right thing. So, if we hit play, nothing will happen because we didn't load a scene. But if we load a scene and then hit play... And I did switch over, right? Yeah, I did. Check that like every time now. I feel like my brain doesn't work. So we got this dude, and he can like strut, and it's awesome, and he can like move up and down, which right now is just magically floating up and down, but we'll worry about depth later. And we can hit this thing, and it has sounds, and it's awesome.
Ooh, that was a neat combo.
Yes, that was a 3-hitter. And it keeps going.
If you go to the other side, will it go the other way?
No, it won't. That's one of our problems right now. We just hard-coded this thing to just add an impulse to itself in whatever direction. So we need to add a little bit more logic or change the way that we address that to actually fix that. I'm not going to focus on that just yet, though. We might fix that up later, too, when we add more hit effects and stuff.
What is Are you using 3D collision or 2D?
We're using 3D. I don't trust the 2D colliders, quite honestly. And you can do anything in 2D that you can't with the 3D engine that you want, so it just might have slightly more overhead. It's not going to be that significant of a deal, though, especially if you don't have a whole lot of colliders. So first of all, let's just duplicate the player and move him, offset him a little bit, so you can just see that, you can have any number of dudes responding to these things, and they should all, like, work. Sweet. And that's basically what we're going to be doing for the NPCs, except for instead of having the same logic, they will have their NPC logic. Could have just a whole army of dudes.
I was going to say, we could have a shadow mode.
Yeah.
You use a power-up item and it creates...
Oh,
like 3 of
yeah, they fall behind it, yeah.
Since we already figured out how to do that.
Yeah, we could grab our option code from the 2D shooter. All right, so enough playing around. So let's duplicate the player this time again. Except for now we're going to make him the bad player. So right now we do the scaling thing right for when we turn around. I just want to make sure. So if I turn around, yeah, we just scale. So I'm gonna make this other dude. This is gonna be called the Nega player. And we're going to flip him on the x-axis so that he's already facing to the left and ready to fight. And we're just going to temporarily just hide our punching bag. I think I'm going to go ahead and make a prefab out of it, though, just so that we have a Actually, I'm going to do it while it's not hidden, so we don't have to worry about that. Prefab, and then we'll just... Actually, we can just delete it now. We don't have to hide it. So we've got this Nega player. Right now, if we hit play... He'll start acting like our main player, although... Oh, that's interesting. That was not what we wanted to do. Because evidently, the way I set up the code, it actually flip-flops it. It doesn't just assume that left means negative and right means positive. So I actually don't want to flip him. We're just going to leave him like that. And we'll have to flip him manually by moving him around. So, where's my scripts? There we go. Come on. Work with me here. Come on, why you gotta be like that? There we go. Finally. So, player movement. Actually, this is basically what we want to look at. So here we're doing movement, and we do it based on our input. And I'm debating on whether we want to... How we want to abstract this. Yeah, let's make it... Let's start fresh. Let's duplicate this, but basically we're going to be changing a lot of it. So we're going to do player movement, and we're going to call this AI movement. AI movement. And actually, yeah, that'll be fine. AI movement... We're going to rename this to AI movement. And let's just try to figure out a really basic behavior. So we're going to have him attempt to walk over to where the player is. So we're going to figure out where the player actually is first. And our player right now is... We can get that information. And while we're remembering this, we should actually untag this guy so that we don't accidentally get him when we try and grab our player. And we don't have prefabs for either of these guys, do we? We have prefabs for the stick man, but not for the actual player container. Yeah, let's jump this over into prefabs for both of them. And so Nega player, what are we doing? So let's first get a private game object. Actually, let's go with transform. Transform player transform. And what we're going to do is in update, we're going to if player transform equals null, then we will fill it with the player tag thing. This means that we'll only have to do this once, and then after that it's just a check, which is very, very fast. So if we don't have a player transform, we fill it with game object dot get find game object with tag, because we only want one. We just want the singular version of that. And oh yeah, this takes a tag. So the tag will be player. We're just going to hard code it because that's appropriate for right now. We could always change this into a string variable up here and pass it in. But I'm going to just leave this as is for right now.
It's called player transform, so...
Oh, yes, so we actually need to put that into player transform. Equals, yeah. The other thing was just a statement that didn't really do a whole lot. So now we're actually setting our player transform. So now we can reference player transform when we're trying to do things. So on here, our movement vector is based on the input get access stuff, but now our movement vector is going to probably be more based on the direction of the player. So what we want to do is we're going to move them towards... we're just going to walk them straight towards us right now. We're just going to have them walk in a straight line. So we are going to replace this section with player transform dot position minus transform dot position, and then we take this whole thing and do dot normalized on it. So this is the direction of our player. We're subtracting the two vectors, and that gives us a vector pointing from transform.position to player transform.position, or you can at least visualize it as that. And then we're normalizing it so that it's a one-unit vector, and that way we can multiply it in speed and time.delta time, and we will get a consistent result. If we didn't do the normalization, we would move faster when we're further away, just because the vector would be longer, and you'd multiply that in. So we're going to save this and just see what happens if we hit play. All right, so first of all, we got a problem. Game object transform. That's what you were talking about. Missed that too. So dot transform. So, and actually, this is technically not safe. So let's actually check for something. So if player transform equals null, this is fine. We'll just do this dot transform.
Well, you put in the game object first, and then put it in
Yeah. We might change that if that becomes a problem. So let's hit play, and here we go, and he's still acting like the player, because he's still got the old player code on him. So we're going to remove player movement here, remove component. We're going to put in AI movement. We may do some stuff to actually reduce the amount of duplication that we've got in this, but for right now we're just working with it. So if we hit play now, there he goes. He's walking towards the player.
Go to the other side of him.
And he's,
Changes direction.
That was easy, wasn't it? So why that was easy is just because all we were doing in the old place is just getting a movement vector based on stick input, and now we just basically replaced the input. And so we can actually have a very if we wanted to remove duplication, I'm not going to focus that on this episode. We might do it later, but one way that we could is to basically have it so that this movement vector is actually passed in from another function, and that other not function, sorry, from another class, so another file. And so then we'd have a player file that just passes in the inputs, and then we'd have the AI file that would pass in movement toward directions, like to the player and stuff. And then all of the actual animation stuff is driven by this system afterwards. So let's make his speed the same as the player, so he looks kind of like the player. So we're going to make his speed 6. And we're going to hit play. And there he goes. And then he freaks out when he gets this, and we're like, "Oh, get off me! It's gross. Stay away."
Be slightly slower. Oh, he is slightly slower.
He's slightly slower when we go to the angles, and the reason being is right now we're using square movement code. If you look at this, we're doing vector3.write times input.getAxis. So this can be between -1 and 1, and this can be between -1 and 1, which means naturally that it's actually more than a circular movement. And this guy is a normalized vector, so it is actually circular movement. So if you move just to the left, you're the same speed. If you move just up, you're the same speed. But if you move 2 directions at once, it's like Turok. You get extra speed. Not sure if anyone ever played the old Turok Dinosaur Hunter game, but you could, if you moved at a diagonal angle by strafing and moving forward, you moved significantly faster.
A lot of games are like that.
This is true. This is true. Especially older games. So now the problem is we don't want him to just go, his goal shouldn't be to go inside of us. So let's try and fix that. Actually, that's kind of interesting that he did settle down at the end there.
He stopped moving, and then it went into a pattern where your arms were one direction and his were the other, and it looked symmetrical. My favorite speed thing, though, doesn't even have anything to do with the diagonals. It was the Battle Block Theater when 2 people are in the boat.
Oh yes, yes, and it goes like
boat 10 times faster.
Yeah, boat movements. If you press, if one person presses to the right, it's like 1.0 movement speed, and then if the other person presses to the right, it's 1.0, and if you both press opposite directions, it just stops the boat. But if you both press the same direction, it's 5 times, 10 times faster. It just immediately just starts gunning. So it's brilliant. What was I doing? So. There was something I was trying to figure out here. It doesn't matter. Oh yeah, how we handle actually getting close to it. We'll figure that out in a second. So let's make it so that he tries to actually get into a punching position for us. And I think the best way to handle that would be to actually, instead of searching for the player, we should actually be instead searching for an object that defines where they want to stand to hit the player. So what I'm going to do is I'm going to create an empty child here, and we're going to put this. We're going to call this.
We need 2.
Enemy target position. Yes, and we will need 2 position. Yeah, that's right. And I'm just going to duplicate that. And we're going to move 1. Let's see. If I just mock this up, I'm just going to create another duplicate of the player for right now, just so that I don't have to remaneuver the other player around and change his scale and stuff once we're done here. So this is probably, arms crossed here is probably optimal. So let's copy this copy component here. We're going to pull an enemy target position out. We're going to paste component values, and then we're going to put it back in, and now it should be offset appropriately. And then I'm just going to make a guess that the other side is going to be exactly on the other side. So we're just going to take this, copy it, and put it at, I find it interesting how close we were on that one to what we ended up going for with the pulling the guy up. So
you copied the negative scale.
Did I? Oh, wait.
I'm not sure it matters because you're only using the position to try and...
Oh, yeah, I did copy the scale. Yeah, let's get rid of that just in case. Just in case that causes weird problems. I don't think it would matter in this case, but...
I don't think so either.
But yeah, so let's hit delete here. Let's save the scene and save the project. And now what we're going to do is we're going to create a tag for these things. So let's call this add tag. We're going to call this enemy target position. And then we go back here, and we're going to tag both of these with this. And so now it's got to work a little bit differently. What we want to do is... we can still cache these, though. Though I don't think I'm going to bother with that just yet. Let's just make it work first. So we're going to do... we're going to grab... Whoops.
We can make a friendly target position and use the same AI code to have NPCs that are on your team.
This is true. Yes, we absolutely can. So, so what we're going to do is we're going to, instead of player transform here, we're going to need a list of things because we're going to have multiple things to look for, and we also want to find out which one is the closest. So, for each game object in, we're going to copy this. We're going to make it game objects, plural, and we're going to change this to be called enemy target position. Enemy target position. And not the dot transform at the end, because that won't actually work here, because we need to iterate over these. So this returns a list of game objects. If we go here, you see this a game object array. So now we've got an obj, and we're going to find out which one's closest. We've done this a few times before. Let's just define float closest distance equals math f dot infinity.
That's pretty far.
Yeah, it's really far. So no matter what, one of these objects should be closer to it than math f dot infinity, if not both of them. So we're gonna do distance. Okay, if obj.transform minus transform.position is... So if this dot square magnitude is greater than closest distance... We're using square magnitude because we don't care about the actual distance. We're just comparing distances here. So this is a little bit faster. It saves a square root operation that is implicit to grabbing the magnitude. So object transform dot minus object dot minus transfer dot position. So if it's less than closest distance, yeah, not greater than. It probably won't be greater than. So closest distance now equals this thing. So we don't want to calculate twice, though, so we're going to pull this out, save it to a temporary variable, which is a float. Square distance equals, and we're going to put square distance here and square distance here. Closest distance equals square distance, and then additionally we need to keep track of which object we care about. So I'm going to create a game object, closest object. Actually, I'm going to call it closest enemy position. So we throw this here. Closest enemy position game object. Equals obj. So now that we have this, I'm going to just temporarily comment this out. We don't really need it. What are we doing? So does this compile first of all? Let's just see if what are we looking at. Missed something here. Oh yeah, missing the forward one there. See if it still compiles. We can't do a minus between... Oh, we need this to be a dot position. Save one more time. Alright, looking good. So now we actually have to use this, though, and we actually have warnings about that. It says we didn't use closest enemy position game object at all. And then this... player transfer is never assigned to, and that's the fact that we commented out player transform, so I'm just going to do that here too. So it gets rid of one of our warnings. And so movement vector now is not player transform dot position. Instead, it is closest enemy game object dot transform dot position. And
It's not
so
null.
that's right. If it's not null,
If it's null, return.
yeah,
or
we'll
something.
just do a right here if closest enemy position game object equals null. We'll just return, just panic and get out of here. There's nothing else that we needed to be doing, right? Nope, all this is movement. So save, hit play. Did something wrong. Stupid thing. Did I spell it wrong?
You might be complaining that you never set
Unassigned
outside
local
of the-
variable.
So you have to set it to null in the first line.
Oh, that's silly. Play. There we go. So now he's freaking out at that point. So that's good. That's really good. Now, actually, so we're running into the problem here. He's a little bit higher than our character is, and that's because our character is kind of crouching down. Which this means that we probably should at this point fix what represents the bottom of our character. So we should probably move this down to the legs. Will that work out for us? Let's find out. I'm just going to give it a shot. So we're going to move the stick man out of the player here for a moment. Actually, no, we're just going to move it inside here. So just do... So there's the player. So it's right at the center. Perfect. So we'll just raise him till his feet are touching the ground. Right there. Let's do that one. So now if we hit player, you'll see that he has a transform at the very bottom here. And we should put his target positions at the same... Oh, they are. Perfect. They're in line with his bottom position now. And we should do the same thing for this Nega player. We just need to position him up. So I'm gonna zero him out so that we can use that line trick. That was freaking awesome. So, and let's hide the player for right now. And we're going to move this up until he's on the line. Looks good. Is that what we had? Yeah, we can use the same one. So 2.2, 2.22. I was pretty close. So now we're going to make the player available again. We're going to move Nega player over to the right. And we're going to hit play. He still is a little higher than us for some reason. Wonder why that is. So if we go to the scene right now, so if I walk, does he not look higher than me? Yeah, it's because when we walk, we kind of move up. So that's our animation being set wrong. We'll fix that later. So let's make it so that he doesn't freak out quite so much when he gets to you. So, what do we want to do? If,
closest distance.
yes, if closest distance is less than a threshold, yeah, I like that. So public float near goal threshold equals 0.1f. Let's go with that. Actually, wait, this is a square thing, right? So let's just do that and see what happens. And what we're going to do is we need to find it out what... oh, wait, we don't need to find out this at all.
Might as well put it in that if statement. If it's null or closest distance, if the closest enemy is position is null or the...
Good point. Oh, well, but I don't want to escape everything because we need to change the logic to not be in walk. Oh, wait, we can do that. Yeah, never mind, because it's a bool. Never mind, you're exactly right. So all we have to do here is this or closest distance is less than near goal threshold. Let's see what happens now. unexpected. Oh wait, we need a semicolon there. Save, play. All right, so he's here, but he didn't stop walking.
And he didn't go to. He still was standing higher than you.
Yeah, the standing higher we have to fix in the animation, so I'm not dealing with that just right now. Oh, I see. So we have this walk, set bool, walk, false. Oh, I see. So we're checking movement vector here to determine if we're walking. So instead of that, we actually just want... we'll do that. Wait, no. We always want this to be set false. Yeah, let's not do it here. We'll do it here. Actually, let's copy that. Put it in here. And we want the opposite of what we want here. We want it if it's greater than the near goal movement threshold. So if we hit play now.
You left part of what was in that statement before. Near goal threshold and movement vector.
Oh, thank you. Save. Play. Alright, so he's still freaking out because he's still moving, so we do need to still stop him from moving, but so else. Wait, no. If it's then we do all this stuff. Okay, so how about we put all this inside of this if statement? That's what we want. So if we hit save here and play. Closer, closer. Still kind of vibrating. And that's because we're doing the transformed opposition movement here, which we want to actually do that in here as well. Save. Play. Oops. All right. We have a contender. Let's see if I can get him to go to the other side. There he goes. He's on my other side.
Punch him. Shadow boxing.
Yeah. I like how that's funny because he turns towards his moving direction. If we move into him, he immediately turns away from us. So we should probably change his movement direction to his look direction to be different than that. Instead of it being based on his look vector, we should have it based on what direction our player is. So instead of doing vector 3 dot right and movement vector, we want to do vector 3 dot right and this thingy. Wait, no, this already is. Yeah, movement vector. Oh wait, movement vector. Yeah. We need the player direction as well. So that's the reason we commented this out. What a joy! Because we need to determine, we need to face the player. So we're changing this to face player. And so this will be player transform dot position minus transform dot position.
Might want to get the player as the parent of the target object.
See, now if I push him back, he backpedals kind of. I mean, he's actually still playing his forward animation, which we could fix that, but I'm not going to worry about that one just for now. I like it. Alright, so now what we need to do is we need to add the ability for us to hit each other. Right now we can punch, and actually we both punch at the same time, and I'm going to leave that for now just so that we can test things faster. But we're not hitting each other. So we have our Fists of Fury, but we need to actually have a hitbox of shame. So what we're going to do is we've got these things. We just put those in the right arm target and stuff. Our hitbox we're going to put at the player level, I think. Or do we want to put it at the stickman level? We don't have colliders anywhere yet, do we? So let's do it. Let's do it at let's do it at the player level for right now. So we're going to create a physics box collider, and we're also going to add a physics rigid body. Whoops, not character controller. Hate those. Physics rigid body. We're going to make it kinematic. This way the collision stuff will work properly. And we're going to make a trigger, and we're going to put it inside. We didn't have to do a special layer for this guy. Perfect. So we're going to put this inside of him somewhere appropriate. So we're going to move it up in the Y and kind of make it bigger. We'll have it so that he has kind of a core that can be hit. Leave the depth of 1. That should be fine. So we'll do this. So right now we have something called, in the upper arm left hand, we have these marked as, oh, they're just the default layer, because we haven't had to worry about that yet. So let's look at our project settings and physics. I don't think we've touched this yet. Yeah, we haven't done anything, so we're going to have to start touching it now. So before, we only had one thing to hit, so we didn't care if what hit it. We didn't do any checking or anything. So we need to start making some layers for this. So we're going to create a layer called player hitbox. Actually, let's call it player damage box. Player hitbox. Enemy damage box. Enemy hitbox. So the hitbox is going to be what we're going to put our fists in, and the damage boxes are what going to be our the thing that we're going to be hitting. So we're going to mark him as a player damage box, this object only, and we're going to go to nega player, and we're going to mark him as well, yeah, same thing, except we didn't actually give him this component. Let's copy this over. I'm going to grab copy component, paste component as new. Whoops, that's not it. Paste component as new. And then the same thing with the rigid body. I guess this one we didn't technically have to copy and paste because it's just a default. Well, it's not default, actually. But it still might have been faster just to add the component.
It's kinematic.
Yeah, so kinematic. So put this guy on enemy damage box and this object only. So let's apply this to our prefabs. And we're not done yet. So what are we doing? So we want to do the same thing with our left hand and right hand, except for we need to put them onto, oops, that's left hand, right leg. So right hand, left hand, and both of these will be on the player hitbox. And then on nega player, same deal. Body, right upper arm, right hand, left upper arm, left hand, grab them both, and put them on the enemy hitbox layer. Now let's actually set our physics settings. So we want player hitbox to collide with enemy damage box. Let's clear everything just for right now in these columns. Let me just close this for a moment. So enemy damage box, all our new ones, we're just going to turn off everything and then turn on what we know that we want. So enemy hitbox should hit the player damage box. Enemy damage box should be hit by the player hitbox. That should be it. So that represents the sum of our interactions between these two types. So I'm going to save scene, save project, And if we hit play right now, everything should still work as it did before. It just... Oh! Evidently, our hit explosions were from a script that's on our hands. Perfectly. Spawn on hit. Yeah. So this actually is already working. I wasn't expecting that. That's kind of cool. No, I'm being hit in the back. No! Alright, so let's figure out our punching and logic for the AI. So right now we have something called punch, and we have something called jump. And both of these are based on buttons. So I'm going to actually just duplicate... Let's duplicate punch for right now. We're not going to implement a jump for the enemy right now, because enemies don't ever jump in Fight Go Right games. It's only the players that can do that. That's why players are godlike. I'm sure that there are some Fight Go Right games where you do see enemies jump, but it actually is surprisingly rare. Reveal and Finder, no. What are we doing? Copying. So Command D or Control D if you're on Windows, duplicate. We're gonna call this AI Punch. AI Punch. Save. So, what I'm going to do is we're going to... So we're already checking our distance. Let's,
Might want to look into AI movement.
Yeah, AI movement. Good point. But what I want to do is, let's actually make closest distance a public variable. Public float closest distance. And the reason I'm doing this is so that we can actually access it from the other script. And we will... What are we going to do? So let's make it so... Let's hide this in the editor, hide in inspector, so that we can't change it in the editor. And what we're going to do is take... we're going to do private AI movement, AI movement, and we're going to set AI movement equals get component in parent AI movement. And
does that go up through parents until it finds?
Yes, it does. That was added relatively recently too. That hasn't been.
It used to only go to one parent.
Used to not exist.
Oh.
Yeah. So you could write your own though. I mean, you had enough data to actually do it. It's just you had to traverse up to your.
It's like 2 lines of code.
Yeah, it's like a couple lines of code exactly. So instead of input get button down, we're going to actually just base it on the near goal threshold and closest distance here that we've already calculated. So we're going to do it's basically going to be exactly this. Let's just grab it. And except for we need to actually say AI movement dot square distance. That's in here, right? Oh, square distance. Oh, it's not closest distance I want to put here. It's square distance I want to put. So float. I may not keep this organization throughout the rest of the project, but so if we set square distance like that, we call this square distance, save, go back to AI punch, and then wait, less than closest distance. Oh, I'm checking the wrong thing. So it is undo. It's being silly. I'm obviously tired. So we do want this just to be closest distance. We're going to grab this here and put it here. And put AI movement dot closest distance. Good. And AI movement dot near goal threshold. Very good. And so if we are closer, if we are within that range, then we set punch not as true. So let's just see if he just starts auto punching when he gets close to us. AI movement does not contain the definition for closest distance. Did I not save this? I did not. There we go. Okay, and he hasn't done it because he's actually still using our old punch routine. So we're going to go to our Nega player here. And it's here where he has punch, so we're going to remove punch, and we're going to give him AI punch. We're going to hit play. And there we go. He just starts.
He's fast.
Yeah, he just starts brutalizing us.
He threw a punch before getting to you, I think.
He threw a punch before he got to me? That might be true. Oh, he did throw one punch. Oh, and I know why, too. It's probably because closest distance probably defaults to 0. And this script should run first, so let's make sure that that happens. So we're going to go project settings, script execution order, and we're going to put AI movement ahead of default time. Hit apply, and so now he shouldn't do that early punch. And he didn't. Let's try it again just in case we missed it. Yeah, he didn't.
So that angle is up and down so that you can punch him in the knees while he's trying to face you down.
Yeah, this is how you can cheese him.
We need to put a stun on him so that you can actually punch him with that.
Yeah, we're going to have to put stuns on both.
Oh, he was punching you right in the face.
So let's first make his AI a little bit less horrifying. Let's go public float attack delay equals let's make it 0.25f. Let's do half a second, actually, it's the default. And so what we're going to do now is, instead of setting punch now to true, we're going to put it at invoke. Whoops. Keep that around. We're going to invoke attack with attack delay. And we're going to create void attack, and it's going to set the bool to punch now. So now the one problem with this is we're gonna have a lot of
just going to
invocations. Yeah, this should make it so that he continuously attacks us still, but he'll have a delay of 0.5 seconds. Now, this is not right though, as we have it right now, because what's going to happen is we're going to get this message every single time, and so it's just going to stack a whole bunch of invokes on each other. So we don't want that. So what we want to do is we're going to create a private bool is attacking equals false, and so we're going to set is attacking equals true here, and then let's see, when do we
want it up here so that it doesn't
oh yeah, good point. Good point. So is attacking equals true, we invoke the attack, and then is attacking equals false here. And we want to only do this stuff if is attacking is equal to false. Or wait, yeah, that's what we want. So let's see how this works. We're gonna save, hit play. Felt like a little bit longer than a half a second on that first delay. 1,000. No?
It did.
It did the first time.
This time, maybe it has to get through its idle animation before it can punch? Or...
Maybe. Oh, yeah, because... Oh, yeah. That's possible. Maybe. Is this what's happening? Here, let's find out. We're gonna start debug logging this.
Well, we can look at his animation, can't we, and see what it's doing? What animations are playing?
Launching attack in a moment. What did you say? We can check to see how his animations is up. Yeah, we can do that. I just want to see what's happening. Launching attack in a moment. Okay, so he totally did that. And then let's see if it's actually just like... Yeah, it still is. So yeah, it did it 5 times before he actually did an attack. Yeah, it is definitely the animation thing, because this thing's going up at the... What is it doing? All right, let's just work with that for right now, and let's do a hit reaction, and let's see if we can do a hit reaction. So we're gonna create a new animation. We're gonna go into what is it called? It's called our Stickman. Here he is. Here's all our glorious animation stuff. So what we want to do is we want to make a getting hit state.
Can we try something just real quick?
Sure. What do you want to
try? Turn off his kinematic on his rigid body. Okay. And disable gravity also.
Why are we doing this?
Oh, it's already disabled. I just want to see what happens if you punch him with... Or is it set up as triggers?
No, it's just set up as triggers, yeah. We're not doing any colliders.
I just wanted to see how his legs and hands would react when his body was moving backwards.
Yeah, that would... they'd still do the IK stuff, but his body would, like, fall, and it would be very strange, and... Well, actually, no, it might not...
It wouldn't fall, it would just keep going
yeah, exactly.
Until the drag stopped him.
Yeah.
Although
well, actually, no, because it's happening...
Well,
the other thing, it wouldn't do anything either because it's happening at this level. The rigid body's happening, and all of his other stuff is happening at the Stickman level, so this would just be moving around like a physics object, but it would be pulling all of his children, including the targets, with it, so... Alright, so what we're doing, we're going to add a damage state. So we're going to do from any state. We're going to give it a shot. So we're going to create, actually let's create the animation first. So let's go to our player. Let's add that window back. Put it down here somewhere. And we're going to grab our Stickman, create a new clip, and our new clip is going to be called, we're going to put it in animations. It's hit reaction. And what will look good for this? So let's grab his body and play with that. Yeah, there we go. That's his hit reaction now. So let's record, and let's just put this at 1 second for right now, and then move him back. And let's go ahead and give him a little bit of a rotate too. That's the wrong type of rotate. Ugh. Let's just try that for right now, and then we're just going to copy this, paste it somewhere at the 2-second mark, which is way too far, and then we're going to make this considerably shorter. So let's see what this animation looks like. That might work. We'll find out. Let's do that for now. So we have an animation. We're going to go into our stickman now. There's our new animation. It's called Hit Reaction. We're going to attach to any state. We're going to put make transition hit reaction. And this will be a new parameter called, we're going to do a bool because we don't trust the triggers, and we're going to do hit. So this will become a transition called hit. If his true, we do this. It's just like this one. If jump now is true, we do that. And then we're going to make transitions to idle and walk from here based on the criteria of very similar to this one. It's going to be just exit time. Oh, wait. We don't have these set up right, actually. Yeah, one of these should be plus bool walk true and walk false. And then this one is going to be the same deal. It's going to be, well, let's do, why is the exit time so short on this 1.9? And walk true and walk false. So if we hit play now, we shouldn't have any changes. It should do exactly what it was doing before. It does. But now we have to actually have it so that we get hit. So we're going to create a new script. And we're going to call it hit reaction. And all it's going to do is void on trigger enter. We're going to need an update here too. Void update. In update we're going to, and we actually need that start too. Void start. The start we need for the same reason that we needed it in the punch thing. We need to have our animator. So we're going to grab our animator here. Then we're going to set our bool and update. We're going to call it hit. And then in on trigger enter, we are going to play hit true. Save, play.
That script needs to be on something?
Yes, it does. So that script needs to be on the player. So we're going to put hit reaction here. And we're going to also put it on the nega player. Hit play. Alright, still didn't work. Why is that? So hit reaction. So it might be because let's do if. Wait, now. What were you gonna say?
I'll put a debug log in the trigger to make sure that it's
okay. Sounds good.
doing that first of all. Can we set
Debug
the bool to
log
false?
Triggered. Can we set the bool to false
In the animator when it's switching states back to walk?
I wish. No, you can't do that. So it said triggered. So yeah, it's triggering on the hits, so that's good. So the problem is...
Wait, who's triggering it?
I'm sure that it's... Here, you want to find out. Triggered, comma, game object. Save. So it's triggering on the player. So, which is what we'd expect. So it's triggering. We're just not seeing anything, and the reason we're not seeing anything is probably because update may be happening after on trigger enter. Is there a way to find that out? Unity order of operations. So execution order is update order, fixed update, update, late update. Where's the trigger? Oh, it doesn't have trigger on here.
Well, we can try an IEnumerator and get rid of the update, and on trigger set it to true, and then run a coroutine that yields one frame and then sets it to false.
It's a good point. We can just do, Is there a way to... I swear there was a way... Yeah, I guess if you want just actually one frame, we do have to use an IEnumerator. Alright, start coroutine. Reset. No. Reset.
I don't know what that does, but
I don't
I'm
know
pretty sure
either.
I don't want it.
IEnumerator. Enumerator. Reset. Reset will do this, but it will do it after a yield return null.
It does the false.
False, yes.
And then comment it out in update. Or comment out all of update so it doesn't even run there.
So let's try that. Save, hit play. Yeah!
Alright. If you hit him, it needs to reset.
Okay, and we can do that. Watch. So if we go into Stickman, there's this coming from any state. There's an extra button, and the button is can transition to self. I don't think this shows up unless it's from any state. So if we click can transition to self, that means that if we get hit...
So now we can stun lock him?
Yeah, now I can just... Yeah, theoretically, although I don't think it's working very well.
No, it doesn't seem to be resetting the animation.
So that totally didn't work. Let's try not saying atomic and see if that fixes it. I actually still don't know what atomic actually does.
I was just going to ask you what atomic was.
I mean, I know what atomic means, but I don't know what it does in the context of these animations. It means it is singular. I think that's what it means, but yeah, so that's not actually solving our problem. Hit true. Yeah.
Maybe it's because of the IEnumerator setting. No? Because that would happen in the very next frame, which is long before your next punch.
Oh well, this is great for an episode, I'd say. I'm going to turn this off because I just really don't know what it's doing at this point. So, thank you for joining us. I think that was a great episode. We got an AI character. He was intelligently seeking the player, and he punches you when you get there, and we have hit reactions, and we can punch him back, and that's super exciting. So, thank you for joining us tonight. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Dracfire. Support us on Patreon. It's Patreon Cooking with Unity. So if you search for us on Patreon Cooking with Unity, or there's a link somewhere in the big hamburger thing. And yeah, you guys have a great night, and I'll catch you in the morning with another Breakfast with Unity. And I'm going on a trip to San Francisco next week. So during Monday, Tuesday, and Wednesday, I am going to be in San Francisco, and I'm not sure if I can do the show. I'm still gonna try to do the morning show, and I'm still gonna try and do the Monday show while I'm down there. I make no promises. I might be able to do the morning shows. The Monday show is almost certainly not going to happen while I'm down there, but we'll see what happens. And thanks for joining. You guys have a great night. I'll see you at 8 a.m. PDT for Breakfast with Unity tomorrow.
Have a good night, everyone.